My name is Hong Liang. I'm from Oregon State University. I'm a PhD student, and I'm going to present some results about climate change impact and adaptation in the Pacific Northwest wheat systems. This is the framework, and we can see that the existing framework includes this part, and we get the climate data and the agriculture census data, then plug into the crop simulation models. And from these models and the ag census data, we can get the net return distributions across individual farms and the relative yield distributions across the grades. And these two components can be combined into TOAMD model, that is trade-off analysis model, to generate some interesting economic, environmental, and social indicators we care about. And what I'm going to do is to add another component, that is econometric model, to use the climate data and ag census data to model the two different indicators. One is the individual climate vulnerability. That is the probability the individual might get lost from climate change. Another is the population level vulnerability. That is the proportion of farmers in this region get lost from climate change, and by how much. These two indicators can be conducted through this model. And this is the preliminary result we get from the TOAMD model based on the crop simulation results for the winter wheat fallow system. We can see that these curves are impact curves, and this intersection point gives us the percentage of farms in this region gained from the climate change. From this column, we can see that on average, in the near term, climate change will benefit farmers in this region on the different scenarios. But notice that these two columns give us intuition that even on average we will gain from this climate change. There are huge distribution impacts. That means some people gain and some people lose from this climate change. So we might not only pay attention to this average impact, but also the distribution impact. So that means this analysis result from TOAMD model gave us an intuition that the climate change impact and vulnerability depend on measured variability of economic returns in response to climate change, not only the average impact. So we will construct an econometric approach to estimate these high-order impacts of climate change on the distributions of net returns. And from this result, we can examine the effect of changes in variability and some weather extreme events. And these two models can also combine together to be compared with the results from the crop simulations to test the stability of the estimates. So this will give us some sense about how best we can model about this impact. And we also consider this direct seeding in this region as a potential climate change adaptation. We investigate some socio-economic factors that affect adoption of direct seeding in this region. And this information will give us some sense about how, what are factors and how they will affect the climate change adaptation in the future. We observe that in this region, some counties have a very high adoption rate of direct seeding, but some other counties have very low adoption rates. We propose some socioeconomic explanations. First, the scale effect. That means some large farms specialized in wheat production, they are more likely to adopt this direct seeding. And the technology diffusion means that this technology, direct seeding might at the stage of the beginning diffusion. So that means people do not know a lot about this technology, so they will not adopt this this direct seeding, and some other social factors like people at the age to retire, they might be less likely to adopt this direct seeding. And the next step is we are trying to integrate some biophysical characteristics and socio-economic factors in this model. And we will get some climate conditions and simulated crop yields from climate group and crop group. And the objective for socioeconomic group will provide some information about management practice. This can be used in the future as adaptation analysis. And within the economic modeling, these two approaches can be combined together to evaluate the climate vulnerability at different levels, either individual level or the population levels. And what we are going to do in the next is to implement more simulations for different various scenarios and to compare the results from crop models and econometric models. So this will give us a stability of the model. So we can finally derive to solve the problem who lost from the climate change in this region and by how much. That is our goal. Thank you.